had a scratch. So you want to avoid scratches. You want to avoid sharp corners. That's why surfaces around it is to avoid. But during the vibration like of the launch, you could start a crack, and if the crack started, you're dead in the water. But again, this device was built before computer machining.
Oh yeah,
computerized machining.
We didn't have any of that equipment back.
So all these curved surfaces were generated using form cutters, where now you would write a program and it would be done numerically.
How many man hours would be involved, say, in just making the telescope as part of it, just as two?
Ken would be the one who could probably answer that question.
Almost unlimited. He told us to take whatever time it took to make a good part. And then, of course, like, for example, the main base, I think it took about 2 weeks, which is about 80 hours to machine something like that. And it was, like Paul says, you know, today you would do it with CNC machining. In them days, for every radius on the inside of this thing, you had to put up on the center of a rolling table and then cut that way. For example, this radius right here had to be set up where there was exactly in the center of a rotary table, and you come up this way and cut that radii and then try to blend it in. And when you get out on an angle, on a radii, you don't really know the intersecting angle. Today in CNC machining, you have a program that tell you go to X and Y, that number, and then you go up on an angle.
It calculates it on the fly. Every time it makes a move, it's doing a trick calculation. So if you're...
In old days, we couldn't do that. We had to set up each, and if you look at it, other side of it, I'm sure that Kenny had it up, or I mean, Les Hughes had it up, and you looked at the inside. There must be at least 15 different radii inside of the tank, and each one of them had to be set up separate.
Just pick it up, and you can pick it up and flip it over.
The other thing is, a CNC will tend not to dwell on the corners, where if you're doing it by hand, mechanically, you end up dwelling in the corners, and that's when shatter occurs. If you look in...
See, this is what I'm talking about. You come up here and go around a radii, and then go up on another angle here, and then there's a little piece in here, and even this had to be cut. And then you had to set it up, and you had to cut this one over here, and you had to set it up and cut the big one in the bottom. And all the other ones seem more or less straight, but there's a lot of guesswork when you start cutting. If I cut up to here, how many degrees do I cut to? There was no way before you go up on this angle. There was no way you could.
So the one of these that Harry made, what he did, he would come in late and work during the night when there were no distractions. The shop was quiet, and he could concentrate on what he was doing. The same occurred at chemistry department. They found that a lot of errors were being made as the parts were being laid out initially. The initial scribing was done, showing the location of various projections and holes and features on the part. And so they ended up taking surface plate and putting it in a quiet room where the machinist could go in with the drawing and lay the parts out without any interruptions or any distractions. And to a large extent, that's pretty much what Harry did, because it required so much concentration that you couldn't be distracted.
See, I did most all of this polishing at night, after everyone went home, Saturdays and Sundays, and you know.
Yeah. Oh,
there's too many interruptions.
Hello.
I was the boss in there, and I had to do some work in the office, and I left orders to the people. When I work on this machine, nobody come and talk to me. I don't want no interruption, because it's all it takes, that you turn your head and that's a mistake.
So you might spend an entire week making this part, and
it would take more than that. A week would get you started. A week wouldn't see it finished. That part is lots more than 40 hours.
Okay.
Yeah, I don't really remember how many hours it was spent on it.
I'd say it's probably not counting the polishing, just the basic machine work on that part is a couple of weeks, probably around 100 hours, somewhere in there. Now that same part done on a CNC machine, how long would that take on a CNC machine, Harry? 8 hours, 6 hours?
But you had a program in it.
No, about 4 hours.
4 hours,
today.
probably.
Yeah, 4 hours.
So you see the difference.
And crank out however many you want.
Well,
Not
absolutely.
only that, but then you'd be absolutely sure there would be no mistakes in it.
Once the machine was set up, the proper tools were in place. You just turn it on and walk away, turn the lights
how
off.
long time it took from one of the guys who worked here, Weitzman, worked on a big telescope in Hawaii, a Keck telescope. And my company, when I left the university, used to make part of a thing we call a shingle tree. And we got paid $27 for a shingle tree. And there was 360 that support the whole mirror system in the Keck telescope. As soon as they got the telescope put up, they decided that they were going to make a duplicate board and link it with a computer and in fact have a telescope where the disc would be the distance from one telescope to the distance of the edge of the other telescope, because you can link it with a computer. Now they needed another 350 or 60 of these shingle trees. This time they went for $5.71 a piece, and I talked to the man that made them, and he said he made money on them because he had the new equipment from almost $30. And this would be the same thing for this one here, the price would have gone.
So why did you wind up having this mostly made in one machine shop and mostly made in the other? Was that just because of the workload?
It was the workload, yeah. There was not that many real good machines.
See, I had men that worked on this portion of it. And we had a lot of time work nights because we were using machines that they needed in the daytime for their regular chemistry work, So a lot of times we worked nights. And of course, I did all the polishing on it. And that was horrendous job. I used to work all night sometimes, just on this little piece here. You can imagine the polishing on it and still staying in powder. I mean, you have to remove a certain amount of material to get a polish like that. And you can't get it too hot or that'll distort it. And,
When you worked like that all night, was this just no extra pay, you just did it, or
I supposedly was told to add up hours, and take the time off, but I never got any time off.
Les, we were not the only ones that worked late hours. Les often would work
all the time,
3 days straight. And, you'd see him, he'd be asleep out in the lobby up here, catching a few hours sleep because he had a certain schedule he had to maintain, having to do with testing. And he would just work straight through.
And after we were done, we were roaring to go again.
Yeah.
Oh, there was fun in them days, We would work also day and night, and some of that stuff. And if we put in 30, 40 hours a month extra time, we wouldn't worry about it.
No.
So is this the one that's going to go to the Smithsonian then, this instrument? This going to the Smithsonian?
This is the engineering model. The proof
So it's going to stay here then?
Yes, this one will stay here. The proof test model is more, it's closer to the flight models. This one has some differences that make it not exactly like the flight model.